Hello! In this video we will discuss the so-called binomial theorem. This theorem provides a closed formula for a plus b to the power n, where n is an integer. For n is equal to 1, this should be a plus b. For n is equal to 2, we have a squared plus 2 times a times b plus b squared. For n is equal to 3, we have a cubed plus 3 times a squared times b plus 3 times a times b squared plus b cubed, etc. For the formula we will need binomial coefficients. To define these, we start with the definition of the factorial. Recall that n factorial is defined for positive integer values of n as the product of 1, 2, 3 until n. This implies that n factorial satisfies the recurrence relation n factorial equals n times n minus 1 factorial. If we define 0 factorial as 1, this formula also holds for n is equal to 1. Now we are able to define the binomial coefficient that is pronounced as n choose k. This is the number of possibilities to choose k elements from a set of n elements. For the first element, we have n possibilities. For the second element, only minus 1 possibilities remain, etc., until finally n minus k plus 1 possibilities for the kth element. Because we can choose the k elements in k factorial different orders, we conclude that n choose k equals the product n times n minus 1 until n minus k plus 1 divided by k factorial. Using the recurrence relation for the factorial, this can be written in the form n factorial divided by the product of n minus k factorial and k factorial. Now the binomial theorem reads a plus b to the power n equals the sum of n choose k times a to the power n minus k times b to the power k. For n is equal to 0, this is just 1, because 0 choose 0 equals 1. For n is equal to 1, we have a plus b, because 1 choose 0 equals 1, and 1 choose 1 equals 1. For n is equal to 2, the coefficients are 1, 2, and 1 again, because 2 choose 0 and 2 choose 2, both equal 1, and 2 choose 1 equals 2. The binomial coefficients can be arranged in a triangular scheme which is called Pascal's triangle. At the top you recognize the coefficients that we have just obtained. The triangle is built as follows. At both sides you only see ones. Every other number in the triangle is the sum of the two numbers above it. For instance, the second number in the last row is 6, which is the sum of 1 and 5, and the third number is 15, which is the sum of 5 and 10, etc. Of course, Pascal's triangle can be extended by adding rows below in the same pattern. This pattern in Pascal's triangle can be written as a recursive formula in terms of binomial coefficients as n choose k equals the sum of n minus 1 choose k minus 1 and n minus 1 choose k, which describes that a coefficient is the sum of two consecutive coefficients in the row above. Furthermore, the numbers at the two sides equal n choose 0 and n choose n, which are both equal to 1, which is easily obtained from the definition. Here is the elementary proof of the recursive property of the binomial coefficients. We will skip this proof in this video. However, if you want to check it, just pause the video for a moment and study the slide carefully. As an example, we consider a plus b to the power 5. The binomial theorem leads to 5 choose 0 times a to the power 5 plus 5 choose 1 times a to the power 4 times b plus 5 choose 2 times a cubed times b squared plus 5 choose 3 times a squared times b cubed plus 5 choose 4 times a times b to the power 4 plus 5 choose 5 times b to the power 5. In Pascal's triangle, these binomial coefficients appear here. So we conclude that a plus b to the power 5 equals a to the power 5 plus 5 times a to the power 4 times b plus 10 times a cubed times b squared plus 10 times a squared times b cubed plus 5 times 8 times b to the power 4 plus b to the power 5. Note that 5 choose 0 and 5 choose 5 both equal 1, and 5 choose 1 and 5 choose 4 both equal 5. Furthermore, 5 choose 2 and 5 choose 3 both equal 10, which can be seen as follows. By definition, both equal 5 factorial divided by 2 factorial times 3 factorial. This can be simplified to 5 times 4 divided by 2 times 1, which equals 10. Another example is, what is 1 plus x to the power 6? 6 choose 0 and 6 choose 6 both equal 1. 6 choose 1 and 6 choose 5 both equal 6. 6 choose 2 and 6 choose 4 both equal 6 times 5 divided by 2 times 1, which equals 15. And finally, 6 choose 3 equals 6 times 5 times 4 divided by 3 times 2 times 1, which simplifies to 20. So we conclude that 1 plus x to the power 6 is equal to 1 plus 6 times x plus 15 times x squared plus 20 times x cubed plus 15 times x to the power 4 plus 6 times x to the power 5 plus x to the power 6. In class, we will generalize this to binomial series. See you then. Bye.